Hello everyone, welcome back. Today's session will plan to discuss more about how we can deploy the Spring Boot application into Docker container. Okay, so instead of running application locally on your laptop, what you can do, you can create the Docker image from your Spring Boot application. Then you can start the Docker container using that Docker image. So let's understand what are the tools we require. We require Docker Desktop tool. Docker Desktop tool is very handy if you want to create application and deploy it as a Docker container. So if you see this Docker Desktop, the console would look like this. So you have image section, you have container section. This image section is for those existing images which comes as a part of Docker Desktop installation. These are the existing images. And if you see this container, this currently is empty. So as there are no applications running, you can see no application container is running in Docker Desktop, right? So these two sections are important: containers and image. Okay. If you scroll down through this image section, all these are system images for this Docker Desktop. We don't have a custom image, so we will build that image, and then we can see that custom image would start appearing under image section. And then if you click on this settings part of Docker Desktop, here you have few more uh, sections like you have Docker engine, right? So by default, we are going to use this Docker Desktop Docker engine to run the containerized application, and then you have also Docker Kubernetes. Okay, so Kubernetes we will plan to cover in next session. So first today's session will try to understand how we can deploy Docker application and then how we can start the container from that Docker image. And then in next session, we will talk about the deploying the same application into Docker Kubernetes, right? So let's go back and see the Spring Boot application from console. So if you see this thread pool management service, so this is the structure of the project. So you will have POM file, then you have the source folder where you have entire code, and then you have target folder where you build the application, then that jar will be placed in the target folder, right? What I have done, I have added Docker file under the root folder threadful management service. So in order to build any uh, application, in order to create any Docker image, what you need is you need a Docker file basically. So you need to place this Docker file under the root folder where you have the pom.xml. And what is the structure of this Docker file? Let's discuss that now. So basically, this is how a Docker file look. So if you see this Docker file, there are a series of steps which are actually used to create a Docker image. So first you are going to define the base image. So we are using Correcto JDK 21, so we are referring to that image. We will define this from JDK image followed by the tag of that image. Right, so we are using JDK 21, so we are going to use this Correcto colon 2100. Then we are going to set up the working directory for our application to run in Docker container. Generally, in most of the cases, we define working directory called /app. So if in most of the Docker file which you see, you will come across the app working directory. So this is the directory from the Docker container where your application is going to run. Then you have the copy command. Copy command is to copy your local jar file into the app directory. So basically what you are saying, we need to copy the jar file from target directory into the thread pool management service dot jar. So if you see this, when we build this application locally, the jar file is created under the target folder, right? So we need to copy the jar file into the app directory. So that is the reason we are given this copy command, copy target slash jar. So what it is going to do, it is going to go to target folder and copy this jar to same name. So the jar with the same name would be created in the app directory. Understood? Then you define the port 8080. Okay, so this is just for information purpose only. You are exposing port 8080. So expose 8080 is not the mapping of your application. This is just to uh, let you understand that this particular application is going to be exposed on port 8080. And then you have the entry point. Entry point is nothing but how you are going to run your application inside the Docker container. So this entry point is nothing but the Java command to execute your jar. So generally we use Java hyphen jar and then we pass the jar name. So this is how you are going to run the jar. So that is what the entry point is. Now you have this Docker file. So you need to create the image out of it. Okay. So basically, there are two ways basically to check the existing images. Okay. You can see the images from Docker desktop straight away, or from the command prompt, you can fire this command Docker images. So you can fire Docker images command. So you can see these are the existing images in the local Docker. Okay. Here you can see we don't have our custom image for this particular thread pool management service. Okay, if you see the start of this Docker image command, okay, we don't see our custom image. So for even if you see from the console, these are the same images which we can see from the command line. So we don't have the custom image over here, right? So what we can do now, we will try to create the image first. So this is the command to create the image. So we will give Docker build and then we will specify the image name. Okay, so let's do that. So this will actually create a Docker image. Okay. So what have you specified basically in this command? You have just mentioned the image name. Okay. And you have given the dot. Dot means current directory. So once you execute Docker build and if you specify the Docker build image name, then that image would be created. And if you want to see that image now, you can again execute the same command Docker images. Now if you scroll up, you can see the images created. So you can see the same our custom image is created, thread pool management hyphen service, which is tagged to the latest tag because we haven't explicitly specified the tag to be used. So by default, image would be created with the latest tag. Okay. Now, if you go back to this console as well and refresh this, you would be able to see the custom image. Okay. So this is a custom image you can see, which is created. Okay. Thread pool management service. So this image is started appearing onto this image section now. Okay, now I want to run this image basically. So I will use the Docker run. So this is basically to start the container. So to start the application, we need to define the container name. So this is the format which we have used to define the container. And then we need to pass the image which we have created in the first step. So this is the image name. This image name, which is nothing but the image which we have created from this first step. Okay. So this was the first step to create a Docker image, and the same image name we have passed to the Docker run command so that this container would be started. Let me copy this command and start this application now. This will start my container. Okay. Now if you go back to this container section, our custom container, you can see our custom container called thread pool management container. What it says basically, container started on local port 8082 and this is currently mapped to the container port called 8080. Okay. Now, why these two ports? Because in Docker run command we have explicitly configured two ports, 8082 colon 8080. The first part before colon is nothing but the host port. So this is the port which we are going to use to access the application from the browser. That's why we call it as a host port. And second port is nothing but the container port. Okay, this is the your service port, container port. So this is the port where your application is going to run inside Docker container. Now if we see this 8080 port should match to the port which you have configured inside your original application. So if you see this service and if you see the application.yml, Here we have configured server port as 8080, right? So this is nothing but the container port. Okay, that is the reason if you see this docker run command, we have not changed any container port. However, we can change host port. Okay, now we have started the container. What we can do, we can just go to the console and access the application on this 8082 port. So now if you can see, application is accessible on 8082 and all the APIs from our service are actually now available to execute, right? Now if you want to access the service from browser using 8080 port, then that won't work because you have configured host port as 8082, okay, inside a Docker container. So if you see this, the container which you have created using port 8082. Okay, so you must need this port to access the application. If you want to access the application using this port, you need to change the host port to 8080. So what we can do, let's stop the existing container. Okay, we will pass the container name. So we will stop this container. So now container is stopped, right? So now container is stopped, and if you try to access the service now on 8082 port, it won't work. Okay, so you won't be able to access the service now because the container is not running now. Okay, so what I will do now, I will remove this container. Okay, and I will recreate the container by using the new host port, which is nothing but 8080. So now you can see our container port is also 8080 and our host port is also 8080. So I will copy this and I will again start the container. Container has been started. If you go to Docker desktop, you can see again this container, new container is created with the same name, but now you can see both ports are now actually pointing to 8080 host as well as the container port. And now if you go to the browser, you will be able to access the service using port 880, right? So that's how you are able to execute API from host port 8080. Understood? So let's try executing this sample API and we'll see how we can check the logs basically from the container. So if you execute this get API, okay, we have received this response basically with the unknown ID. Okay, so now we have received 200 response. Now, if you want to see the logs, there are two ways basically. So you can go to local Docker desktop, click on this container, then there is a section called logs. If you scroll down here, you can see these logs here. So that's how you can access the logs from the Docker desktop. Another way to access the logs is using again command line. You can give Docker logs, again pass the container name, Docker logs. You need to pass the container name over here. So I will copy the container name. And here you can see the logs. So logs are actually rendered on this terminal. You can see the same log on command line as well, right? So that is all about executing your application on Docker desktop. So this time, if you notice what is changed, the last time we have run this application locally from IntelliJ itself. Today we have run this same application using local Docker desktop. Okay, so any request you are executing from the browser, that is actually going to the local Docker container. So Docker desktop. Understood? In the next session, do, what we are planning to cover in the next session basically. So Docker desktop also comes with Kubernetes cluster. Okay, so if you click on the settings over here, and then if you go to Kubernetes, here there is an option to enable Kubernetes. Okay, so once you enable Kubernetes, there are multiple options like how many clusters you want to deploy your application locally. So basically, you can create single node cluster or you can create multiple node cluster. Okay, In the next session, what we will cover, we will use the local Docker Desktop Kubernetes cluster. We will create a single node cluster, and then we will deploy our same Spring Boot application onto Kubernetes cluster. Okay, and then we will able to see how we can access this Kubernetes application from the UI. Okay, so let's keep this for the next session. For today's session, you can just revisit the Docker file, how to create this Docker file, how to execute these steps locally, and then how you can see the image as well as how you can see the container basically from the local Docker desktop. You can see that. Okay, so see you then. Let's catch up in the next session for steps for Docker Kubernetes.